Understanding the basic boot process of a Linux system is fundamental for system administrators and crucial for troubleshooting and managing Linux environments. The boot process involves several stages, starting from the system's power on until the Linux operating system is fully loaded and operational. Let's explore the key components and stages involved in the Linux boot process, along with essential commands and tools. 1. Basic Input-Output System, BIOS. The BIOS is the firmware that initializes hardware during the booting process before handing control over to the bootloader. Here's what happens in the BIOS stage. Power on self-test. Post. The BIOS performs a post to check the system's hardware, such as memory, CPU, and connected devices. Boot device selection. BIOS searches for a bootable device, such as a hard drive, USB, or network boot, based on the boot order configured in BIOS settings. Key points. BIOS is stored in non-volatile memory, like flash memory, on the motherboard. BIOS primarily works with legacy systems, but many modern systems use UEFI instead. Unified Extensible Firmware Interface. UEFI is the modern replacement for BIOS and offers several improvements, such as faster boot times, support for larger storage devices, and secure boot features. Unlike BIOS, which operates in 16-bit mode, UEFI operates in 32-bit or 64-bit mode, allowing for more advanced features. Key features. Secure boot. UEFI can ensure that only trusted software is loaded during the boot process, which helps prevent rootkits and other malicious software from taking control. Graphical User Interface. GUI UEFI offers a more modern GUI-based interface compared to BIOS, which is text-based. Bootloader. GRUB 2, Grand Unified Bootloader version 2. After BIOS or UEFI has selected the boot device, it hands control over to the bootloader. For most Linux systems, this bootloader is GRUB 2. GRUB 2 is responsible for loading the Linux kernel and initializing the system. Key functions of GRUB 2. Displays a menu that allows users to select which operating system or kernel to boot. Loads the kernel and the Initramfs, initial RAM file system. Supports booting from multiple operating systems, dual boot. GRUB 2 commands. GRUB 2 install. Installs the GRUB 2 bootloader on a device. Example. Sudo GRUB 2 install /dev/sd. This command installs GRUB 2 onto the master boot record, MBR, of the /dev/sd disk, which is typically the primary bootable disk. GRUB 2 config generates a new GRUB configuration file, /boot/grub2/grub.cfg, based on the current system configuration. Example. Sudo GRUB 2 config o/boot/grub2/grub.cfg. After modifying kernel or GRUB settings, use this command to update the configuration. GRUB 2 update updates GRUB 2 to reflect changes in the system. This is essentially an alias for GRUB 2 config on many distributions. Files associated with GRUB 2. /boot/grub2/grub.cfg. This is the GRUB configuration file that contains the list of kernels and operating systems to boot. /etc/default/grub. The main configuration file for GRUB 2 where settings like the default boot entry are set. Initial RAM disk, Initrd, and initial RAM file system, Initramfs. During the boot process, the initial RAM disk, Initrd, or initial RAM file system, Initramfs, is used to load necessary modules, like disk drivers, that are required for mounting the root file system. Initrd.img, a temporary root file system loaded into memory during boot that contains necessary drivers to access the real root file system. Linux, the compressed Linux kernel file that is loaded by GRUB 2. Commands. Initrd. This command generates an Initrd image. Example. Sudo mkinitrd /boot/initrd.img $uname r. This will create an Initrd image for the current running kernel. $uname o gives the current kernel version. Drakit, a modern tool that generates an Initramfs image. Drakit is highly configurable and can include or exclude specific drivers and modules. Example. Sudo drakit force/boot/initramfs on mstr.img on Initrd. This regenerates the Initramfs image for the current kernel version. Boot sources. During the boot process, different boot sources can be used, depending on how the system is configured or what external media are available. Pre-boot execution environment, PXE. PXE allows a system to boot over the network. It's often used in environments where system administrators need to perform remote installations or boot diskless systems. PXE works by downloading a small bootloader from a network server, which then continues to boot the system. Key features. Network-based booting, no need for physical media. Useful in large-scale deployments. Booting from USB. Many Linux distributions allow booting from a universal serial bus, USB, device. This method is popular for system recovery, live environments, and installing new operating systems. To boot from a USB, the BIOS/UEFI must be configured to prioritize USB devices in the boot order. Steps to boot from USB. Plug in a bootable USB drive. Restart the system and enter BIOS/UEFI settings. Change the boot order to prioritize the USB device. Save and exit the BIOS/UEFI, and the system should boot from the USB. Booting from ISO. Booting from an ISO image is commonly done in virtualized environments or when using tools like QEMU and VirtualBox. ISO files are disk images containing the entire content of a bootable medium, CD, DVD. Example for virtual environment. In a virtual machine like VirtualBox, simply select the ISO file as the boot medium when setting up the virtual machine, and it will boot as if it were a physical disk. Handling kernel panics. A kernel panic occurs when the Linux kernel encounters a fatal error from which it cannot recover. This typically freezes the system, and you may see a screen filled with technical information. Common causes: corrupted or missing kernel files, hardware failure or incompatibility, invalid configurations in grub or the kernel. Troubleshooting tips: boot into a different kernel version from the grub menu if multiple versions are installed. Use a live CD or USB to repair or reinstall the kernel or necessary modules. The Linux boot process starts from BIOS/UEFI, continues through the bootloader, grub2, and culminates in loading the Linux kernel and necessary file systems. As a Linux administrator, mastering these components allows you to troubleshoot boot issues, configure systems to boot from various sources, network, USB, etc., and manage critical bootloader configurations. This knowledge is essential for maintaining uptime, performing system recovery, and ensuring smooth system operation. Next, we'll explore additional core concepts of Linux system management.